For this one, there's an identity that I don't talk about that much because we don't see it that much when we work on trigonometric identities. Okay, tangent, there's nothing wrong with this guy. You guys shouldn't have a problem with him. This one you guys might have a problem with because there's a negative inside there. Okay, so let's talk about the values of sine really quick by looking at a circle, okay? Look at a unit circle. Now, if you guys went to this angle right here, we'll call this angle pi over 3, right? What is sine at pi over 3? Like it's 1/2 rad 3 over 2, right? Right? Okay, so sine is rad 3 over 2 at pi over 3. Correct?
Yes.
Okay, now I want to think about, well, what about negative pi over 3? Where would that be? That would go the opposite direction, right there, right? So that would be negative pi over 3. And then what are the coordinates there at negative pi over 3? That'd be positive 1/2 and then negative rad 3 over 2. Like it switches to negative because now we're below the x-axis, right? Okay, so let's try another one. Can you guys give me another angle that'll be at in one of the first two quadrants?
Pi over 2.
Pi over 4? Okay, that's cool. It's in the first quadrant though. Actually, yeah, I take it back. I want one that goes in the second quadrant.
3 pi over 4.
Oh, sure. Let's do 3 pi over 4. Okay, so this is 3 pi over 4. Do you guys know what the coordinates are right there?
Negative rad 2 over 2.
Rad 2 over 2, rad 2 over 2. One of these is negative. The x is negative. Okay, notice how the y value is positive, and this is your sine value, right? The sine is always the y value. What if we did negative 3 pi over 4? Okay, so same angle but the opposite direction. What are the coordinates for this one?
Negative rad 2 over 2, negative rad 2 over 2.
And then this one's also a negative, right?
Mm-hmm.
So this is what you're paying attention to. That guy. Is there like a conclusion that you guys can draw from this?
If it's a negative.
If the angle is negative, then the answer will be the opposite sign, right? Does that work for even? Let's try this. Let's try to go to quadrant 3. Let's try quadrant 3. So if I have an angle that goes all the way to quadrant 3, so here's my circle. Here's an angle. Let's call that one 7 pi over 6.
Sure.
Okay, those coordinates for 7 pi over 6, they're both negative. It's going to be rad 3 over 2 and 1/2. And so this is your sign right there. Now, what if I go the opposite direction? I go negative 7 pi over 6. Will I get the same thing, but the opposite sign?
Yes.
Yes, it will. See if I go like this, 7 pi negative. This is negative 7 pi over 6. So the coordinates right here are negative rad 3 over 2, and now it's positive 1/2. Oh, see, check that out. So whenever you have a negative inside of sine, that just changes the value to the opposite sign, right? So what can I say if I know this? What can I say? Sine x equals 1/3. So now I can ignore him because he's scary looking, and I can find the rest of them. Right? Yeah? That's it. So how would we find cosine? If we're using identities, which is what you're supposed to be using in this chapter, you're supposed to be practicing identities. Some of you guys won't. You guys will do the triangle way, which we talked about yesterday. But if we were using Pythagorean identities, you would say 1/3 squared, that's sine squared, plus cosine squared x equals 1. And this is 1 over 9. And so cosine squared x equals 8 over 9. Are you guys okay with that? I did that really fast. I subtracted 1/9 from that side. I subtracted 1 over 9 from this side. The common denominator would be 9 over 9 minus 1 over 9, which would be 8 over 9. And then how would I get the cosine alone? I would square root the dude. Okay, now I'm going to say plus or minus because I don't know yet if it's positive or negative. Let's see. The square root of 8 and the square root of 9. That simplifies. We have plus or minus. We have a 3 on the bottom, and on the top we have was it 2 red 2? Okay, so is cosine supposed to be positive or is cosine supposed to be negative? See, if sine is positive, what would cosine have to be so that tangent is negative? Wouldn't cosine have to be a negative so that we would go positive divided by negative so we get a negative? Yes. Or you guys can think about which quadrant you're in. If sine is positive, then we're in the first quadrant or the second quadrant. If tangent is negative, then you're in the second quadrant or the fourth quadrant. So the overlap is in the second quadrant. We have to be in the second quadrant. Therefore, this has to be a negative answer, not a positive answer. Okay, so there, I found cosine. I found sine with you guys. Now, since we have sine and cosine, we can find all the other ones. We can find cosecant, we can find secant just by flipping these, finding the reciprocals. We can also find cotangent just by flipping tangent. So that problem is finished.